So, how are you all? Just give me a moment, and as usual, just let me check if I'm live yet. Let's check once and then we will get started. Yes, I am live, and let's share this to our Telegram channel so that everybody comes here so that we can all study. Give me a moment. Yeah, and it's done. Cool. So here we are right on the platform of Unacademy, ISC and ICSE boards, and here together we are going to ace your exams. Okay, we are going to boost up your performance as well as your grades. So it's gonna be like an amazing journey, I should say. So let's begin. Let's get started. Let me change it quickly. Yeah, so now we are at the right window. Let me open it in my phone so that I can just go through your comments. Okay, yeah, now it's all set. Now it's all set. So let's get started, guys. So what are we gonna study today? So we will be doing what? Your lecture number 2 of, yeah. So we are going to do lecture number 2 of chemical kinetics. Which chapter is it? It is your chemical kinetics. Can you guys see that? Just give me a moment to let me check. Okay, so here you anyway can't see what I'm writing. Okay, so let's write above what we are going to study today so that you guys can see properly. So we are going to do chemical kinetics today. It is chemical kinetics. I hope that now you guys can see this, right? We are going to do chemical kinetics, and today is our lecture number 2. Today is our lecture number 2. So if right now you have not downloaded the Unacademy app, then just simply download it, and you can unlock the free live classes by this code. You can unlock the free live classes. I'm like emphasizing it again that these are free live classes. Nothing costs you. And then on the platform, if you feel like, wow, this is the way we want to study, then you can take plus subscription. Then you can take what? Plus subscription. And if you apply this code, that is Kirti S Live. The code is Kirti S Live. If you apply this code, then you will get additional 10% off. See, you can see here, you can get additional 10% off discount. All right. So that was like a quick introduction. Let's go ahead with my introduction now. Some of you might know me that my name is Kirti Sharma and I am your chemistry educator for class 11 and for class 12. All right. And I have done my graduation from University of Delhi, and I have more than 5 years of teaching experience, you can say. And that's me. So let's go ahead. Let's begin the class. But before that, the Unacademy champions, the like you can follow us on Telegram. The description, the link is given in the description. So go through it, you'll find it. You can, then join the Telegram group then. And subscribe to us on YouTube right now if you're new. The current, we can say the target we have right now is only of 1,000 subscribers. So help us. That's the only thing. You are the only one who can propagate us, promote us, and especially if you are an ISC or ICSE board wala bacha, then propagate it within your school group, friends group, so that we can all be here. All right. So let's get started with our chemical kinetics. And as I mentioned, that today is lecture number 2. Today's lecture number 2 of chemical kinetics. This is our chemical kinetics. This is our lecture 2. All right. So let's begin. What we're going to do today right now is we will just quickly go through some things which we did in the previous class. All right. And then we'll do some question solving. And then we will do some more new concepts. So let's get started, guys. Before this, let me tell you one thing. Just give me a moment. Yeah, all right. So let's begin. What we did in the previous class was like we studied what chemical kinetics is, what is the rate of reaction, how does it get affected, right? That's what we did in the previous class. So we did, I have written it down so many times no in this class that this is your chemical kinetics, all right? So if we look at the graph, we didn't do the graph in the previous class. So if we look at the graph, graph of what? Concentration over time. Say here we take concentration and as usual time on the x-axis. So what you're going to get? We know that if you take reactant, so reactant starts from 0, right? So the graph goes something like this, right? And for the another one, right? Just give me a moment, guys. Yeah. So, yeah. So can you guys see me now? I hope yes, I'm back. Just let me check. Yeah. So correct. So where were we? So I was telling you, if you look at for the product. So for the product, the graph will be something like this. The product will be formed. And in the case of what? For your reactant will be reached to like this. So this is like how your graph looks like in case of chemical kinetics. All right. This one is for reactant and this, sorry, oopsie, this one is for product and this one is for reactant and this one is for product. Let's write it this way only. Okay. So like after the equilibrium has been achieved, after the equilibrium has been achieved, this is the part we study in equilibrium. But this part when like product is formed, reactant is getting consumed, this part we study in chemical kinetics. Okay. And what else we did in the previous class? We saw that for a reaction A gives you B, a very simple reaction. A gives you B. So how do you write the rate of disappearance of A? You write minus dA over dt is equal to minus of dB by dt, where this is the concentration of A and B. This will be minus of dB by dt, right? This is your rate of disappearance of A and this is your rate of appearance of B, right? This is how it works, and I told you that it works on the like stoichiometry as well. Since यहाँ पे stoichiometry is the same for A and B, that's why this expression comes out. Then I told you that for a hypothetical general reaction, if I say for a hypothetical reaction, for a hypothetical reaction, I write AA plus BB gives you CC plus DD, for example. Then how do you write the rate of reaction? Then how do you write the rate of reaction? You say that minus 1 by small a minus 1 by small a into dA by dt will be equal to minus 1 by b dB by dt. And since now we are talking about the product, so the product will have, hi Gulshan, how are you beta? Since now we are talking about the product, so this will be plus 1 by c dc over dt, and now it will be equal to plus 1 by d dd by dt. हाँ बच्चे पहचान लिया. I recognize you. Of course, I recognize all of you, bache. Okay? So, yeah. So, that's what your rate of reaction expression comes out. If I talk about, okay, let's modify it a bit more. I can also say that rate of reaction is equal to 1 by A times into rate of disappearance of A. Rate of disappearance of A. I can say this now. Kyunki, what is the rate of disappearance of A? Simply minus dA by dt. Minus of dA by dt. This expression. I told you na that this is your rate of disappearance of A and rate of appearance of B. Arey bache, I was here only. Don't worry. Bache, now I am teaching chemistry here. Gulshan, now I'll be teaching chemistry here. Alright. So that's what we can say, that rate of reaction can also be expressed as 1 by A into rate of disappearance of A. Can also be expressed as 1 by B into rate of disappearance of B, and it can also be defined as, let's go ahead, your rate of reaction can also be defined as 1 by C into rate of appearance of C, into rate of appearance of C. And similarly, it can also be written as 1 by small d into rate of appearance of D. Why? Because C and D are the products. ये क्या है? These are the products. So these will be formed, these will appear, and the reactants will disappear. So this was the relationship which we did not do in the previous class. Right now I am telling you this. हाँ बच्चे, I know. नहीं बच्चे, Gulshan, this is of ICSE and ISC boards. Okay. All right. So I guess that this is clear to you right now. There is no issue till now. That what is the relationship between rate of appearance or disappearance and the rate of the reaction. So if somebody asks you like what is the relationship between the rate of appearance of A, rate of disappearance of A and rate of disappearance of B. So how do you say that? You can say that minus dA by dt will be equal to A by B dB by dt, right? Minus of A by B dB by dt. So that's how you say. So you are going to equate the rate of reaction. How you will be equating? By using the rate of reaction expression. You will always write the expression which is used for the rate of reaction. It means this one. You will always equate using this expression only. So that's a very important thing which you need to know. So I guess abhi tak koi doubt nahi hai. If you guys have any doubt, then let me know in the comment section or like on the Telegram group or in the special class or plus class as well. Okay, bache. All right. So let's do some questions now. Let's look at some. Bye, bache. So now let's look at some question now. So for a reaction, half A gives us 2B. We have we have been asked the rate of disappearance of A is related to rate of appearance of B by the expression. So let's do one thing now. We have given the expression as half A. Half A is giving us 2B. So if we multiply both the sides by 2, what do we get? We get A gives us 4B. This is the same expression, right? Same equation. So what can we say? That minus of dA by dt, we are writing the rate of reaction wala expression, and then we will calculate the rate of appearance or disappearance, like whichever is asked to us. So what can I say? I can say that minus of dA by dt is equal to minus of plus of 1 by 4, because this is your product side. So this will be plus 1 by 4 dB by dt. So see, the rate of the reaction itself expresses that the rate of disappearance of A, that is minus of dA by dt, is related to rate of appearance of B by 1 by 4 dB by dt. So this will be your correct option. So let's look at the options. Ames lover. Okay, hi bacha. So let's look at this. So the very first option says minus dA by dt is equal to 1 by 2 dB by dt. No, this is not the correct answer. Let's look at the B option. Minus dA by dt is equal to 1 by 4 times dB by dt. Exactly. That's what we have calculated. Cool. So I hope that this question is clear to you. This was our question number 1. If you guys have any doubt, just let me know, whether like in comment section or you can just join the Telegram group and let me know. Or else you can just connect with me on Unacademy Messenger. On Unacademy Messenger. If you like download the app, go in the category of ISC Class 11 or Class 12, or you can just simply write my username. My name is Kirti Sharma and my username is Kirti underscore Sharma 1 223. This is my username. So we can get connected on like Unacademy Messenger if you guys have any doubts, on plus sessions, like on YouTube, or like if you're new to Unacademy, then you can just unlock my live free class, free live class by using my code. And my code is what? Kirti S Live. My code is, let's write in the Kirti S Live. You can use this code. All right. Okay. So let's move ahead with the next question. So the question says, hi, bache Ames lover. Okay. So we have been told to consider the reaction N2 plus H2 gives us 2NH3. This is the reaction which is given to us. So we have been told the equality relationship between dNH3 and minus dH2 by dt is. So in the first place, let's write the rate of reaction expression. What would be the rate of reaction? You can say that the rate of reaction will be minus dN2 by dt is equal to, this will be equal to minus 1 by 3 dH2 by dt, and this will be equal to plus 1 by 2 dNH3 by dt, dNH3 by dt. So now let's look like what are like किन के बीच में हमको relation बताना है. So we have been asked to tell the relationship between dNH3 by dt and minus dH2 by dt. So we can say that dNH3 by dt is equal to what? Minus 2 by 3 dH2 by dt we can say, right? That's what we can say, no? और dNH3 by dt का ही हमको वो बताना है. So we can say what? By equating the second and third, हम कह सकते हैं that, yeah, right, it will be simply minus 2 by 3. This is the correct option. We can say that इस 2 को simply आप इधर भेज दो. Shift this 2 here. So we can say that dNH3 by dt will be equal to minus 2 by 3 dH2 by dt. dH2 by dt. So that's your expression when you equated these two. All right. I hope that this is clear to you. Let me see if you guys have any doubts. No. Let's check once. All right. So we can move ahead now. Now let's look at the next question. For the reaction 2A plus B gives us 3C plus D. Which of the following does not express the reaction rate? All right. So let's write the rate of reaction expression as usual. So we can write that minus 1 by 2. We can say that minus 1 by 2 dA by dt. We can say that minus 1 by 2 dA by dt will be equal to minus of dB by dt simply. It will be equal to now plus 1 by 3 dC over dt, and this will be equal to simply d d by dt, right? So let's see कि इनमें से कौन सा एक्सप्रेस नहीं कर सकता, कैन नॉट एक्सप्रेस, डज नॉट एक्सप्रेस. माइनस dB by dt करता है, so that's why this is not our correct option. Plus dd by dt, it is also correct. Minus 1 by 2 dA by dt, see ये तो तीनों correct है, बचा क्या option number D. Minus 1 by 3 dC by dt, see this has to be plus here. If this was plus, it would have been the correct rate expression, but since here it is minus, so that's why this is our correct option, because we have been told to mark the incorrect option. All right, so that's why this is our answer. So please do not confuse, like whenever you are asked to write the correct expression or the incorrect expression, sometimes what happens is you forget कि we have been told that which of the following does not express. Sometimes we are like, which of these express? We just look at the option number 1, minus dB by dt, and you are happy. Wow, ये तो express कर रहा है. So that's why this is your answer. So don't do this, okay? Don't do this. All right. Just let me collect my charger once. All right, let's go ahead. Till then, I've called somebody. Which of these does not influence the rate of reaction? Which of these does not influence the rate of reaction? So we saw the factors which influence the rate of reaction, right? And those factors are what? चार्जर लेना मेरे लैपटॉप का, यहीं कहीं पे होगा. Right. So we have been told कि which of these does not influence the rate of reaction. So nature of reactants, it does. We saw concentration of reactants, yes. Temperature, yes. But molecularity, we will study in this lecture only what is molecularity, and it does not affect the rate of reaction. It does not affect the rate of reaction. Just give me a moment to yeah, so now it's okay. Cool. Now let me see if you guys have any doubts so that I can just go through your comments. Yeah, right. The correct option is option number D. Okay. Now let's move ahead. For a reaction of the type AA plus BB gives us product, then minus dA by dt. Now what is this minus dA by dt? This is your rate of disappearance of A. Rate of disappearance of A. All right. Okay. Let's let's write the expression which will be equal to minus 1 by A. Now we are writing the rate expression. Now this will be minus 1 by A dA by dt will be equal to minus 1 by B dB by dt, right? So from here, what can we say? That only minus dA by dt, this minus included, only this minus dA by dt means the rate of disappearance of A will be equal to what? It will be equal to, let's write a very simple equation. Minus dA by dt will be equal to minus of A by B dB by dt, right? Is there any comment? Not right now. So this will simply be minus A by B dB over dt. So let's look at the right option. That's option number C, right? Minus A over B dB by dt. That's your correct answer. So I hope that there is no doubt till now. Let's move ahead. Let's proceed to the next question. In a reaction, 2x plus y gives us x2y. The x disappears at half the rate that of disappearance of y, the same rate as that of disappearance of y, the same rate as that of appearance of x to y, twice the rate as that of appearance of x to y. All right. So again, what we are going to do? We are going to write the rate expression. We'll be writing the rate of this reaction which is given to us. The reaction is 2x plus y is giving us x to y. So let's see what will be the rate of reaction. So here the rate of reaction will come out to be minus 1 by 2 dx by dt, concentration of x over dt. Now this will be equal to minus dy by dt, simply, correct? And now this will be equal to dx2y by dt. This will be simply the rate of the reaction. So what we need to check, the x disappears. So we need to calculate the rate of disappearance of x. So this will be in terms of, let's check in terms of y. In terms of y, right? This is our y. So that will be twice the rate of y and twice the rate as that of appearance of x to y, correct? You will, like, you can just shift this to here or here if you just want to calculate minus dx by dt. So you can say, see, twice यहाँ पे सिर्फ option number D में है. So minus dx by dt will come out to be twice the rate at which x to y appears. So we can see that. So this is our correct option. So the x disappears at twice the rate as that of appearance of x to y. All right. So that's how we calculate. I hope that there is no doubt till now. Let me check if you guys have any doubt. Any doubt, bacha? Let me know in the live chat section. I am checking. Piyush, all right. Okay, bacha. Hi, how are you? All right. So during the course of a chemical reaction, the rate of reaction. Now, when the chemical reaction is proceeding, the rate of reaction, what happens with the rate of reaction? It remains constant throughout? No. That's great, Piyush. Increases as the reaction proceeds? No. Decreases as the reaction proceeds? Hi, Tanve Purvar. Okay. Books reviewer recommended your channel. Okay, bacha. And you recommend this to your friends, especially if you are from ISC or ICSE boards. I am Kirti Sharma, your chemistry educator. And today we are doing Chemical Kinetics, a term 2 chapter of class 12. And this is your lecture number 2 of Chemical Kinetics. You can just simply watch lecture number 1, and right now we are doing some problems based on lecture number 1. So if you haven't watched it, go and watch it. Okay. And if you guys have any doubt, let me know right now in the live chat or comment section, or simply you can join the Telegram group. All right. I have watched. Okay, Tanmay. That's great, beta. Refer it to your friends as well. Okay. So during the course of a chemical reaction, the rate of a reaction decreases as the reaction proceeds. जो rate होता है, it keeps on decreasing as it goes towards the completion. All right. Okay. Now, next question. For a hypothetical reaction, 2A gives us 3C. 2A gives us 3C. The reaction rate R in terms of the rate of change of concentration is given by. Now again, we have asked rate. So let's write the expression. It will be minus 1 by 2 dA by dt, and this will be equal to plus 1 by 3 dC over dt. No new comment. dC over dt, right? So let's see. Minus dA by dt cannot be the rate of change of concentration. No. R minus half dA by dt बिल्कुल सही आंसर है. Option number B is absolutely correct. The next is 1 by 3 dA by dt. No. Or simply dA by dt. No. The correct answer is option number B. Minus 1 by 2 dA over dt. So very simple, very easy. We are doing these questions so that you will be comfortable with like rate of appearance, rate of disappearance, and rate of reaction. All right. Now comes next question. In an experiment to study the reaction, A plus 2B gives us C plus 2D. The reaction is A plus 2B gives us C plus 2D. Alright. The initial rate minus dA by dt at time t equal to 0 was found to be 2.6 into 10 raised to power minus 2. Okay. C. So we have been given that minus dA by dt. It means the rate of disappearance of A has been given to us. And this is 2.6 into 10 raised to power minus 2 mole per second. Correct? So, we need to calculate the value of minus dB by dt. We need to calculate the value of minus of dB by dt. So, how are we going to do this? We will, as usual, first we will write the rate expression, rate of reaction, and that will be equal to, according to the reaction, it will be equal to minus of dA by dt will be equal to minus 1 by 2 dB by dt. Correct? Now we just need to calculate the value of minus dB by dt. This minus and dB by dt. So this comes out to be minus dB by dt. कितना हो गया? इस 2 को इधर भेज दो. A very simple equation. So it will come out to be 2 times of minus dA by dt. Minus dA by dt. So it will come out to be what? 2 into 2.6 into 10 raised to power minus 2. 2 into 2.6 10 raised to power minus 2. Correct? So this comes out to be how much? 5.2. 5.2 into 10 raised to power minus 2. That's your answer. Simple. That's your answer. I hope that this is clear to you guys. How we calculated this, very simple and very easy. Now let's go ahead. Alright, so we are done with the questions for now. We are done with the questions for now. Now we need to see what is law of mass action. Now what we're going to see? The law of mass action. So this the law of mass action says that the rate of the reaction, Piyush Kumar Gupta, yes. So the rate of reaction is directly proportional to the multiplication of the, the masses, molar concentration of the reactants raised to the power equal to their stoichiometric coefficients. Let's write the definition first. Let's write the definition first. So, write rate of react. Just give me a moment. So we can say that rate of reaction is is directly proportional to the multiplication of what? To the multiplication of the molar concentration. Above, now you'll be like, ma'am, whose molar concentration? Multiplication of molar concentration of reactants. So what do we did till now? The rate of reaction is directly proportional to the multiplication of molar concentration of reactants. You took reactants, their molar concentration, and you multiply them. Now, again, we have something as well. So rate of reaction is directly proportional to the multiplication of molar concentration of reactants raised to the power equal to their stoichiometric coefficients. Raised to the power equal to their stoichiometric coefficients. Stoichiometric coefficients. That's what the law of mass action says. And the stoichiometric coefficients are as in the balanced chemical reaction. Your reaction should be balanced in the balanced chemical reaction. In the balanced chemical reaction. All right. Now, let's look at a general example. If I tell you that XA plus YB, let's talk about the reactants only. XA plus YB gives you products. XA plus YB gives you products. So according to the law of mass action, according to law of mass action, what do we did? That the rate is directly proportional. Rate is directly proportional to the molar concentration of reactants. So let's take the molar concentration of reactants. Okay, multiplication of molar concentration of reactants raised to the power equal to their respective stoichiometric coefficients. Raised to the power equal to their respective. Let's add this word, respective stoichiometric coefficients. So A to the power X and B to the power Y. Their corresponding, you can say the stoichiometric coefficients. So we can say that rate is equal to, if we remove this sign, the proportionality sign. So a constant will be added here. Rate will be equal to K, A raised to power X and B raised to power Y. This is what the law of mass action says. Okay? Is it okay, everybody? Is that okay? What is the rate of, the law of mass action is? This is the law of mass action. Now what we are going to do? The next thing which we are going to do is the rate law. It is the rate law. Now, rate law also says the same thing, that your rate of reaction is directly proportional to the multiplication of molar concentration of the reactants raised to the power equal to. Now, here is something different. Raised to the power equal to the coefficients on which the rate of reaction actually depends. So this may be something different. Say, let's take the previous example only. The example we had was XA plus YB gives us products. Correct? But now according to the rate law, this rate comes out to be the multiplication of molar concentration raised to the power equal to the such numbers on which the rate actually depends. They may be some alpha and beta. Let's take them some alpha and beta, something like this. All right. So here, this is the concentration of A. This is the concentration of, okay, so we are talking about this one. All right. So here, the power M, N and P, which may or may not be equal to the stoichiometric coefficients. Now here, in this example, these alpha and beta may or may not be equal to the actual stoichiometric coefficients. So that's the difference between your law of mass action and rate law. Okay, let me see if there is any comment. Okay, so I hope that it is okay till now, I believe. All right, this we are writing for a reaction. Okay, we have already written. Great. Which may or may not be equal to the stoichiometric coefficient reactant respectively, and this goes on depending upon the number of reactant in a chemical reaction. Cool. So I hope that this is clear to you right now. All right. Now, so rate law expression. This is a very important statement for you guys. So rate law expression and law of mass action are different from each other. Sometimes students get confused between the two. Right, ma'am? It is the multiplication of molar concentration raised to the power equal to their stoichiometric coefficients. The one which is the law of mass action. In this, these are the coefficients which are present in the balanced chemical reaction. But in the case of rate law, these coefficients are like on which the rate of reaction actually depends. Now let's move ahead. So rate law expression and law of mass action are different from each other. And one of the main differences is that in rate law expression, the concentration of reactant is raised to some power which may or may not be equal to the stoichiometric coefficient of reactant. But in case of law of mass action, concentration of reactant is raised to the power equal to their stoichiometric coefficient of reactant, as in the balanced chemical reaction. As in the balanced chemical reaction. As in the balanced chemical reaction. Okay, so that's the major difference between your rate law and law of mass action. So let me see your comments. if there is any. I have no idea, like, where are these spammers coming from? Hmm. Okay. Let's go ahead, guys. So if some of you like might be watching it after, like, after this live session ends in the recorded form, so let me tell you, if you are not available on Unacademy app right now, then go download the app, and and you can unlock the free live classes. I'm telling you again that these are free live classes, and you can unlock them by using my code, and my code is Kirti S Live. Kirti S Live. All right, this is the code for which, through which you can unlock the free live class, and you, if you plan to take plus subscription, an academy plus, at which, like, we cover the whole syllabus, and very soon, like on 3rd of January, the plus batch is getting launched. All right, so you can take plus subscription, and if you apply this code, you will get extra 10% off after applying this. Extra 10% off you will get. Okay, so I hope that this is clear to you, and let me know if there is any query, any doubt. We will get it sorted. Now, the last topic of today is the difference between the order of a reaction and molecularity of the reaction. Since right now we did what? We did the rate law and the law of mass action, right? Even before it, let me tell you what an elementary reaction is and what complex reactions are. So, an elementary reaction is which gets completed in a single step, which gets completed in a single step. And what is a complex reaction? As the name suggests, that it is complex. How is it? It is the complex reaction. So, complex reaction is the one which occurs in more than one step. In more than one step. All right. So, that's the major difference between elementary reaction and your complex reaction. Now let's come to the order of the reaction and molecularity of the reaction. Now these are the two terms in which sometimes we get confused. Sometimes, all right. So let me tell you what is the meaning of order of a reaction. So as you can see on your screen, that it is the sum of exponents of the concentration in the rate law. It means the powers on which the rate of the reaction actually depends. This is not law of mass action. Here we are talking about the rate law equation. Okay, so it is the sum of exponents of the concentration in the rate law equation of any chemical reaction. That is what you mean by order of reaction, right? Like in this particular, say, in this example, you can say that order of reaction, what you can say, that order of reaction is equal to alpha plus beta. The order of the reaction will come out to be alpha plus beta. See, it is the sum of the exponents of the concentration in the rate law equation of any chemical reaction. So that's what you can say about the order of the reaction. I hope that this is clear to you. All right. Now comes the molecularity of the reaction. So we know that a reaction takes place when the ions or molecules like collide with each other, and the product is, consequently, the product is formed. So now the molecularity is the number of atoms, ions, or molecules that need to collide with each other in order such that the reaction will happen. If these number of atoms does not collide, they do not collide, then the reaction will not happen. So that's the molecularity of the reaction. For example, let's say two atoms or two ions collide with each other in order to make the reaction happen. So in that case, molecularity is 2, because two atoms or two ions or two molecules collided with each other. So that's your molecularity of the reaction. All right. Now, the order of the reaction does not need to be a whole number always. It may be a fraction as well. It may come out to be a fraction as well. But when it comes to molecularity, you cannot say na the half atom collided with 1.5 atom. No. Molecularity is always a whole number, that two atoms collided with the three atoms of another, for example. You can say that. So order of a reaction may not be, I should say that the order of reaction can be a fraction or whole number. But when it comes to molecularity is always a whole number. It cannot be a fractional value. Okay? It cannot be a fractional value. Now, the order of the reaction you cannot calculate on pen and paper. You cannot calculate the order of a reaction. You have to do some experiments in order to get the order of the reaction. So the order of the reaction is always calculated experimentally. It is always calculated experimentally. And in case of molecularity of the reaction, it can be calculated by simply adding the molecules of the slowest step. Now, this is a very important thing, of the slowest step. Okay? Because in case of complex reaction, the slowest step decides the rate of the reaction. Now, there are no separate steps written to obtain it, and for the molecularity, steps are important because molecularity of the slowest step is significant here, because rate of the reaction depends. See, the speed of the reaction will obviously depend on the slowest step, right? The slowest step is, the slower the slowest step is, more the lesser will be the speed of the reaction. Correct? So that's how these things are connected. And that is it for the day, bacha party. Okay, thanks. That is it for the day. And if you guys are not available on the Unacademy Learner app, go download it, and again you can use my code, that is Kirti S Live. Okay, and there we are discussing some different topics of term 1 and of term 2, so you can join the class. And if you plan to take the plus batch, then this code, by using this code, you can get extra 10% off. Okay, so that is it for the day. See you soon in the very next session, and we will discuss the rest of the chapter. Till then, bye bye and be safe. Okay, so bye bye.